guys, hopefully we are only 5 minutes late, so that's great. I don't know if some of you found the demo. I heard some people that are quite close, so please rush. Once you find the sentence, you have to understand who is who. Just say it. Okay. It's my true privilege to introduce to you Attila. I have some problem with your last name. Szantner. Szantner, actually. It's more easy to pronounce than to spell. And Jérôme, and your name is also complicated. Waldispühl. They will talk about a just fantastic subject, kind of sales application for some people, but not the users of a game inside a game, or so on. It's a bit complicated, I think. You will see, it's just great.
I'll probably use this. Can I switch this one? Yeah, this one. So thanks a lot for the kind introduction. And for the patience, we have a little bit of technical difficulty. So today we're going to talk about video games and citizen science, and you might be wondering about the strange title. There is this expression video game payer, which is something that you might have never heard about. Me neither. This was something of a sort of a Freudian slip, I think, in the program, and for historical accuracy, we decided to keep it here as well. What you see here, this is a real-life, massive, physical arcade machine. It's something that is rarely the focus of game-related conferences nowadays, or probably ever. But believe me, this is something which is highly relevant in 2023. This machine is currently on exhibition in Zurich at ZHDK, the Museum of Gestaltung. And so if you have the chance to go there, it's still visible until mid-July, if I'm not mistaken. They have a really nice game design exhibition. The machine itself is a piece of art. It was created by a company in the US that are creating props for major Hollywood movies. I believe that they created the props for The Mandalorian. So it's really, really something special. But more importantly, this is a physical arcade machine that was born in the virtual world. And so if you want to see the original of this arcade machine, it's this one. This one can be found in on Sanctuary 3, which is a spaceship in the Borderlands 3 video game. And if you go to the medic bay, then you find this arcade machine. And today I'm going to talk about how this arcade machine got into the Zurich Museum of Gestaltung, but also in Borderlands 3. So just to give you a little bit of idea how perfect remake of the virtual one, the physical one, so I wanted to switch back a little bit. It's really worth to check out. So I'm Attila Szantner, I'm the CEO and co-founder of Massively Multiplayer Online Science, which is a small Swiss company. Also I'm an adjunct professor at McGill University. And although I'm going to talk a lot about science today, I'm not coming from academia, but more from software development. And already me, I'm not I don't consider myself young anymore, unfortunately, but already me, I was growing up with video games. So video games was something that was a everyday experience for ourselves. This was my first next-gen console when I was a kid. And so it was really fascinating to see these couple of decades of development of the industry, how video games became something of that was considered something almost like a pointless, nerdy activity, mostly for young boys, to something which is one of the most important form of entertainment of today, and serving something like 3 billion people. And we've seen that games are just really everywhere. And if you look at the story of how it was unfolded, how Facebook or Meta wanted to create the metaverse and is struggling and mostly failing with it. And as a contrast to that, we see how Epic, which is primary video game company, without even uttering that word metaverse, they are very successful in building a very complex experience in the virtual space, and we see how video games really became the focal point, or one of the most important focal points of our virtual lives. So I would argue that seeing that we have a responsibility to try to find solutions and try to find clever ways to extract value out of all this time that we spend in these virtual worlds, and what we're doing is an attempt to do that. So the other thing that I'm talking about today is citizen science, and we're talking today about this citizen science, which is one of the definitions would be the involvement of the general public in the scientific research process. And it takes many forms, it's nothing new. Already in the online scene, it has been there for 15 years. One of the first big successes was Galaxy Zoo, which later became Zooniverse. And even if you haven't heard about the term citizen science, I'm sure you've heard about projects like Foldit, which is the protein folding crowdsourced mini game where we try to help researchers better understand the secondary structure of proteins. Or another example would be iWire, where we are trying to help scientists to map the visual neurons, if I remember well, of a mouse by analyzing these black and white images. Or another example would be Fido, which is one of the most successful ones, and by the way, it's Jérôme is the founder of this citizen science project, which is a DNA multiple sequence alignment minigame aiming to help geneticists to have a better way to analyze this kind of data. Now, citizen science always fascinated me, and I think it's quite an amazing concept that us outsiders can chip into the scientific process. But in reality, what happens is that this is a highly repetitive activity, often, and what we've seen that users are really bouncing off from these services and mini games. So most citizen science projects suffer with user acquisition, so to find new users, and user engagement to keep them on the platform. So that's where the story started roughly 8 years ago, when we started massive multiplayer online science, and that was our core idea, is to take these citizen science activities and integrate them with already existing video games, so that they became an organic part of these bigger virtual universes, let's say. And this integration would mean an integration with the narrative, an integration with the visual language, and also with the reward system. And so we thought that if we managed to make it happen, then we probably can tap into a new resource which was unavailable previously for citizen science. And so one of the first projects that we started to work on was together with EvoLine. It's made by an Icelandic company called CCP. This is one of the biggest science fiction themed massive multiplayer online games. This year they will celebrate their 20th anniversary, which is in itself an amazing feat that you can create something in the entertainment industry that remains interesting and relevant and intriguing for players. And so we approached them, and although I had no previous contact with the gaming industry, they were really open to this idea, and relatively quickly in AAA timeline we managed to implement the first project together, which was a collaboration with Human Protein Atlas in Sweden. Their research team were curating a large open database of microscopic images of human cells and tissues. And we took the subcellular atlas, which contains these beautiful immunofluorescent microscopic images, and we created a small minigame inside EvoLine, which looked like this, where the player was presented one of the 250,000 images from this data set. And they were asked to localize the green staining, which was which signified that there is a certain protein on that part of the cell. This became an instant success in EVE Online. The player base immediately embraced this, the whole concept, and they started to contribute to the project. I have a lot of interesting numbers about that, but I think what tells most about how successful it was that one of the things that EVE Online designers created was a suite of rewards. And this was the Sisters of Eve combat suit, which was the ultimate reward. And of course, game designers made some estimations of how much time would it take for the most active players to unlock the biggest reward of the game. And they were calculating with something like 3 to 4 weeks. The first one was unlocked in 17 hours after launch, and the second one 6 minutes later. So that's when we knew that this is going to work beautifully for science. On this project, this was our first major scientific publication. It's quite remarkable in the sense that Nature usually does not publish fake science, but they thought that this is important enough, so they greenlighted to show non-existing spaceships on the cover of Nature Biotechnology. This was also an amazing tool for engaging with the community. This was the first ever Citizen Science Live tournament, where we, at FanFest, which is the player convention of EVE Online in Reykjavik, we do this live tournament so players could play with the minigame. On the red-haired guy is the CEO of CCP Hilmar. There is Emma, the lead researcher, and some guys from the research team. And the main reward was a lab coat for the Human Protein Atlas signed by all the research team. In 2017, we switched to another project that was in exoplanet research, together with the University of Geneva. And we used the so-called transit method to search for new exoplanet candidates in the data set. The transit method basically takes these luminosity graphs, and you see dips in this graph. And if you see a periodic dip, it might mean there is a planet passing in front of the star and blocking a part of the light coming from the star. And this is the interface that was created inside the game. So all the tools that you need to analyze this data set, which is basically trying to find signal in the noise type of problem in citizen science. One of the things which was very important from the beginning is the narrative integration. And this was working beautifully with this project, where Michel Mayor, who here, I don't need to introduce him too much, but he's the guy who discovered the first exoplanet and got the Nobel Prize for it 2 years ago. He was part of the project, and he got an avatar in game. He was the one, his avatar gave you the quest to solve these problems. But also he came to FanFest once personally to give a talk and mingled with the players and talked with the players. And this image was published in Ars Technica, and I love it a lot. Background, you see the beautiful facade of the Harpa, the Reykjavik Opera House. On the right, you see Michel Mayer. On the left, you see the Space Pope. This guy is cosplaying as one of the religious leaders in the game. And in real life, he is Chief's Education Officer at NASA's Jet Propulsion Laboratory. So that's about the rich facets of this project. And here is this I took from YouTube of some of the comments on Michel Mayer's presentation at FanFest. And it's really the kind of response that researchers want to see, the kind of engagement and inspiration when you do science communication and science outreach. And of course, for that project, we also had some really nice cosmetic outfits and some cool spaceship skins. Now, one of the things that we anticipated from the beginning, even when we started to talk with these game developer companies, that probably journalists would be interested in it, so it's a kind of a good way to do additional PR for them. It worked out way better than we ever dreamed of, and the story was covered in major journals around the world. I mean, EVE Online is one of the big games in the game industry, so they're often covered because of different things that are happening in the game, but having an article in the New Yorker, that's not obvious, and this project was covered in the New Yorker and BBC in many places. Just last year we had 3 major documentaries, one is running on Amazon Prime about these projects. And we also got some really nice awards, like this one, or the Innovation Award from the University of Geneva, or the Lavie Awards, which we didn't know about, but previously it was handed out to people like David Attenborough or the European Space Agency, and it was quite fascinating that they decided that a video game-based project is worthwhile to stand in this line. Now in 2020, we started a new project, and that was together with Jérôme, when I received an email from Berger, who is the creative director at CCP, and he asked me whether we could help in any ways, and that was around the first wave of COVID. And very quickly, since everything was already set up, all the tech and all the components were in place, very quickly we managed to set up a new project together with McGill University and BC Cancer Vancouver and the University of Modern and Regional Media to analyze these images to present a clustering problem for players. These are images which are a high-dimensional data set coming from the human blood, and by analyzing it, we help researchers better understand how the immune system reacts to certain conditions, COVID being one of them. And here I want to show you a video, and we have a little bit of problem with the sound, but it's subtitled, so I think it can work. And the reason why I show this video is this is a short interview which was on BBC, and I find it really interesting because they interviewed a player, so it tells a lot why a player would participate in such an activity.
Secondly, and probably the more important part is just how relevant it is to me. Like, I can finally relate to this. It's really just like citizen science to a T. We had a giant group of people, and we made this fun. We gamified this quite a bit. There's incentives for people to do it now. Booster hear about the COVID research or COVID going on all around the world. A lot of people, like have had it or know someone who's had it, and just the fact that I can sit here at my desk while I'm working doing something that's going to contribute to helping find out information about COVID-19. That's just phenomenal that I have this opportunity just playing a video game. I think that's really kind of what got me into it, is that I can sit at my desk in the comfort of my home and I can help researchers do something, make a difference. That's kind of cool.
Now in 2020 we released another project together with Gearbox. Borderlands 3 is one of the major IPs of the game industry. I believe in 2019 it was the biggest top grossing new release. And it's a game which is a first-person shooter looter. So in the teaser trailer there were these kind of taglines, and this is something where you don't really believe that these kind of almost meditative scientific activities or mini games could work at all. Partly because if you want to be any good in the game, you have to have put your 150% of your attention to it. So it was really interesting to see how game designers go about it. In 2020 April, the game was released in 2019, and in 2020 April there was a free update to the game which contained a small mini-game called Borderlands Science, and that's exactly when this arcade machine appeared in the game. So this arcade machine appeared at the Medic Bay. There was a new quest, you could go there and start to play the mini-game. This mini-game, there is a video that Jérôme will show to you, so we'll explain much better, and Jérôme will talk about it much more in detail. It's basically a new implementation of the Philo citizen science project that Jérôme was developing for many years. So I already showed you that this is the Philo mini-game where you shuffle or try to align the base pairs of small DNA fragments. And what happened is that Gearbox game designers took this original concept, redesigned it a bit, made some changes which made it much more enjoyable and digestible, and also, of course, they fitted to the Borderlands 3 visual language. And in 2020 April, we put it into the game. So this is very interesting for us because we have quite a good comparison of how such an activity works in a classical web-based setting and in a video game. The day that we introduced this feature inside Borderlands 3, we collected 5 times more data than during the 10 years that Jérôme was running this project. So this is the kind of power that gamers bring to citizen science. Now, these projects work really nicely, but we have identified a couple of bottlenecks in the last 8 years. There are 2 major bottlenecks that the game developers are super busy. There's simply too much for them to deliver. It's not that they're looking for new features in the game, but they try to deliver on deadlines. So it's in retrospect, it's almost a miracle that we managed to pull this off together with CCP and Borderlands. There are certain research projects which are really worthwhile to support, but when we start to talk with the researchers, it's clear that they will never make it to a AAA video game, and that can be for many reasons. Maybe the data set is too small, maybe just it's too complex. So if you remember the Foldit example, there's no way that the game developer would dedicate that much resources to implement that inside the game, and so on and so on. So there is a new thing that we're working on, which I believe can, again, be a very substantial move forward in this initiative that we started, is we're implementing a new mobile app. And the mobile app in 2023 doesn't sound to be too revolutionary, But what we're trying to do here is we are trying to keep the connection with games. So we're trying to keep this sort of DNA of our project, but decouple it from the games a bit. So it would work almost like a companion app to major games. We believe that this would lower the commitment that we would expect from game companies. So we could develop the mini games ourselves, but would still keep the players engaged because we would keep this activity in the reward loop. So while players would play in this mobile app, and at the end of the day get home in front of their PCs and consoles, they could use this sort of rewards that they accrued inside the mobile app to get their favorite guns or specific skins in the games that they play with. Also, we are thinking about decoupling the rewards from the actual experience, which is important so that we can support citizen science initiatives which are not one-to-one connected to a major game, but we can tell players that, hey, we see that you're very active in, let's say, Borderlands science, try this one out, and you will get the same kind of rewards in Borderlands as with the other project. So this is the thing that we're working on, and now I pass it over to Jérôme to give you some more details about research.
Thanks, Attila. All right, so what I would now, which is the second part of the talk, when we try to speak more about the specific project of modern science, because we believe that it's a milestone in the way we do in citizen science. And I try to convince you also that what we're doing here is not just gamifying science, it's so bringing back and changing the way we're scaling up research to do science at a scale of society now. And we do that thanks to video games. So let's try to go back first. I'm a computer scientist at McGill University, Montreal, Canada. And initially my field of research was bioinformatics. So, I mean, I'm developing algorithm to study the shape of RNA proteins interaction with molecules. And when I was a step back, try to understand first what does it mean to be a scientist, what's the scientific method. And the classical presentation, I mean, there's many diagrams, these wheels that we can show, but this simple one works quite well here, is like usually we don't really have access to reality, right? We have a mathematical, a model representation of the world that we use to interpret the world around us. And to understand if this model is good or not, we're making hypotheses, and we're testing them through experiments. Give us a feedback about reality. And then when you get the result of the experiments, we're taking this result, we're analyzing and potentially point out discrepancies and compare them to the model to correct the inaccuracies of the model. And you can go on and on like this because there's no model that is a perfect incarnation of reality, but we try to get better at every step. So the key part that's interesting for us here is really this part when we're analyzing the result. And usually it's done because you know that nowadays we are working on computers. It's really a scientist sitting back with on the desk with his computer, cracking numbers, and having a scientist interpreting the analysis of the computers to correct the model eventually behind. And this is an important part for me because this is what I'm working on, but also that's the one that have key issues in terms of how do we work with it. So the problem these key steps here is difficult for many reasons, but the two main ones that I want to point out is first that the problem we're facing here when analyzing the data are extremely difficult, being by nature. They often belong to categories of problem called NP hard. Basically means it's super difficult, and if you want to find an optimal solution, you need to run your computers for centuries. But I would eventually argue that it's not the most difficult part of it. It's mostly because whatever mathematical model or computer model you're using, you don't have, you cannot encapsulate, I was saying, completely the reality. So the scoring function, the score that you're using to tell what's the quality of my model, is just partially reflects some aspect of the problem, but not all of it. And in science, it's always what we're facing every day. It's like we're computing some scores, some qualities, but we need someone behind to contextualize the finding and understanding it. And how do we do that? Well, by involving a brilliant researcher there. And arguably, we recognize all Marie Curie here. We're probably one of the most famous geniuses of all time in science. And this is a vision that we have about science. Like we have a genius scientist sitting in a desk and solving all the problems for us, and we don't have to understand it. But the problem we're facing is that, well, modern science is no longer like this. I mean, like we have many different types of data we're collecting, data sets, and all of these data actually turns out to be very specific and narrow to a very field of research. So you need specialists for almost all these different types of measurements of reality you can do. And you need to have to merge all these specialists together to create the research. And the truth is that the way science is done nowadays, it's done by teams. I mean, it's not a single scientist, but it's really teams of 10, 100, thousands of scientists working together to achieve these major advancements of the common knowledge. And we reach a point nowadays that if you look at the major populations, like the 4D nuclear project, the ENCODE project, the LHC, if you look at the author list, you have to go to the supplementary material nowadays, because there's so many researchers involved in there that we cannot list them and put the name up front. So how do we address the problem of scaling up? By the citizen science, when typically we need to involve people into the science to help us and compensate for the lack of trained scientists that we would need to classically perform the science. So as you can guess from the talk of Attila here, of course, the solution we try to bring here, because we have massive amount of data, so we need massive amount of participants into this project. And for doing this, we need to we use the video gamers to help us solving the problem. Because if you think about it, so playing a video game is solving a problem. It's what we're doing by playing is solving a problem that generates hormones that basically make us happy and want to solve more problems. And when you're considering the vast potential of players, with virtually more than 3 billion people playing video games all around the world here, if you can tap into this potential, we have the resources we need to advance the research, as was mentioned. So our first attempt to address this was with Philo, as Attila mentioned. It was this video game we launched in 2010. It was a summer project. I mean, so I remember I was back at MIT, was discussing with my office mate, and showed me they were saying, okay, let's do something like what Louis von Hahn was doing, what he called the concept of game for purpose. So you may have known by the ESP game at this time. We started thinking about what type of problem could be addressed with this. And a couple of years later, when I arrived at McGill, I hired two undergraduate students, Alex Nafikov and Jérôme. We implemented this small interface of solving one of the most fundamental problems of genomics we call the multiple sequence alignment. So the idea is that you take fragments of DNA, try to compare them to see similarities, and it's very important for us as scientists because these similarities can reveal genes or functional features of our genomes. And so we implement this interface the best we could at this time. And of course, it's not like when I'm speaking about citizen science and practical numbers involving people, it's not only done by people, because here we're speaking about aligning genomes of 3 billion characters, and we have hundreds of them. And you cannot give all these data to one single player. So really the idea is to see it's like human computer systems, when you have first computers cracking and making the first approximation of the alignment, then you extract the fragment of it that you play in the interface, and then after reinserting it. The reinsertion is a bit complicated, I won't speak about it, it's quite technical, but it's not just copy-paste, of course. But when you look back at what makes Philo a successful and viable project, it's because it was based on 3 major pillars. The first one is that it was a fundamental problem in molecular biology. When you do citizen science, it's very important to remember you don't want to address a niche problem that would just be interested for one couple of scientists around the world, because we're speaking about trying to involve as many people as possible. So the topic should be of broad appeal for the community. 2, of course, it has to be a very well defined problem, and a problem defined and found to be complex for computers, because otherwise there's no point of using computers. In the case of alignment, it's because the similarities trying to find are similar but not identical, and the border, the threshold, both by saying that something is different or the same, is very fuzzy one. And this is because humans are capable of making intuitively setting up this threshold that it works. But most importantly, this is what I think was the main novelty actually of Philo here, is that for the first time we're trying to embed that into a casual time-matching game. So making a game that is accessible. One of the main novelty of Philo was that you don't need training to do it, to play it. That wasn't the case in previous games. And you don't need registration. You could go to the web page, play for 1 or 2 minutes and leave, and you still make contribution. So it was really about opening the game to anyone. And it works quite well. So we had about more than 500,000 people that contributed over 10 years, more than 1 million solutions collected, and we proved that it worked, and we improved the alignment for most of the methods. We compare all methods to the state-of-the-art algorithm, and we showed improvement. So the concept works. Although there was one bad news with Philo, that even if the concept works, it not works well enough. Because eventually the goal we want to reach here is like, how do we bring that for the most hardest topic on research today? And one of them is the study of the human microbiome. So I don't know if you know it, but I mean, roughly more than half of your cells in your body belongs to microbes. We're mostly aliens to some extent. And one of the major research in health research nowadays is understanding how these microbes can influence our health and our well-being in general. And for instance, we found connection to Alzheimer's. We have, of course, connection to obesity, diabetes, and these kind of things. But I mean, that plays a major role. The problem now is like we have too much data. So how do we solve that? And of course, this is where MMOS and gets in place. So I was starting to think of this problem when I saw the EVE Online project out, and I get in touch with Attila, who basically was telling me that it's yeah, that sounds interesting, let me think about it, to see what we can do about it. And in a couple of years, because setting up this project is not that easy, you cannot say, so maybe I found someone that would be interested to integrate your game into the game. And it turns out that this company was Gearbox, developing this Borderlands franchise. But when you look at Borderlands, that's really a first-person shooter looter. I mean, who would think about doing citizen science within this type of games? We're speaking here of having the biggest gun, as many guns as possible, and shooting aliens. So that seems like to quote Attila, an unlikely match, a marriage between activities. Yet, here we're speaking about what we need to do for this project, was really involving hundreds of thousands, millions of people. So that's typically the type of game where we need to do that. And by sitting here, that the process, like once we agree that it was a cool project, that the game has the potential to be integrated, then we start sitting with game designers and try to redesign the game to end up with this revival version of Philo that is Borderlands science. And so there's many things we could speak about the design of the game itself for hours too. But there's many important change that was done here. The fact that playing vertically, to play with gravity and giving a better sense about the weight of your actions within the game that are translated for us into weight of evolutionary events. There's also my own perspective in the design. I don't see it like just, actually, what was very interesting during the work of the game designer is not just a version adapted with just the graphics of Philo that has been adapted. There was really a fundamental work done at the way we play it. Because if you see the way you play the game, basically you have all this grid collapsing to the bottom, and you have to introduce these yellow tiles at the right places. But this is no way, it's not how you work in science here. I mean, we don't give you a specific number of tiles and try to put it at the right places. But what we tried to, but it was a mechanism suggested by us, by the game designer. And by working, scientists and game designer together, we found a way to make this game mechanism relevant for the scientific task that we have in here, which is what we're calling here this kind of a game-first approach, where we try to first think about what game we play with and try to make it scientifically relevant instead of the opposite. But the success of this was not just designing the game, that's not all you integrated into the platform, the game itself. And as I mentioned, remember the cabinet we see at the beginning, this is the cabinet where you play Borderlands. It's based on the main spaceship of Borderlands, it's called GSGS'23. And it's basically a place where you can chill out while you are waiting for friends, going to out of missions. And it turns out to be a central social hub for this experience. And it was a key element when you put it there because this is where you can attract the attention of people. And of course, you have boosters and different skins that you can collect from it. So we benefited of all the engagement system of this video game already in place. And as Attila mentioned, I mean, I think the Borderlands has been a success well beyond what we initially imagined. So we collected, I think, more than in Alpha Day, more than 10 years of data with FIDO. And I would argue also that data is more complex and more interesting. And now, up to today, we had more than 4 million participants that contributed, and we collected 130 million solutions to the puzzles. And the puzzle that we have, so you showed the easiest one, but some of them are super complicated. I wouldn't even myself be able to complete them, but turns out some players are quite good at it and perform quite well. So I think we can confidently say that this project is probably the most, or it's one of the most successful and popular citizen science project ever released. So what are we doing with results? So again, I won't go into detail here, but there's many things that opportunities open now through the data we collected and through this media that we're putting in place, because now you can play your favorite video games and be doing science into it. By collecting this data, of course, we're improving this alignment. Well, this is kind of tricky, so this is basically almost a scientific slide, but with cool video game design, because we don't know the ground truth. So the best you can do is collecting aggregate evidences that you have improvement. That's what we're doing. But of course, in this era of AI, that's also open new opportunities. Because one of the goals of citizen science is like, well, usually why on this problem we don't have an AI solution? We just have done enough data. I mean, it's too specific, there's too broader context to interpret the result, that an AI solution doesn't work at this stage. But by integrating this and trying to harness the collective wisdom of researchers collecting the solution we collected there, we can now open the door to AI solutions. So for instance, in the context of microbiome alignment, our goal is and what we're doing now is training agent that will be able to customize the best algorithm to the specific problem and having in the future not having to result on the players and citizens to do this specific task. We move to something different. And of course, beyond that, and I will conclude with this, there's also all this other opportunity opened by these techniques. So this, Attila mentioned about all the impact it got on the press coverage and the recognition was there. But there's also this feeling that, and actually now there's two, I remember this, the BBC video shows really that this, it really helps to empower people. So beyond the scientific result itself, it helps to have participants finally being able to not be simple spectators of the scientific process, but being part of it. And it doesn't matter at which level it is, because even the simplest one is significant for them. And then when you start playing this game, what you do by playing a game is you create emotion. And when you create emotion, this is where you start moving people. You don't move people by exercising logical argument and try to make your point by demonstrating that you're right and the other one is wrong by fact. It isn't not how it works. It works by creating emotion of people, and typically what these games are doing is creating emotion while doing science. And by doing this, you're reinforcing the public trust into science. So eventually, what I think Attila believe too is like what we're trying to do is not just helping, like say, during science, but it's creating new generation of knights for science, basically of people empowered by science and embracing the freedom that science can give you. So just to conclude this is all the people that work on the Borderlands. I mean, not all, but the one I didn't forget. All participants of the project, and the founders, and Attila promised at the very end we can show you the trailer of Borderlands Hands, which is a masterpiece of art, and often it's able to convey exactly what we're doing in much less work than in that for the last 20 minutes. So let's try to play it. We should try it, yeah. Give it a shot. If we don't hear anything, just, yeah.
Hey folks, this is Maya Biology, actor, PhD scientist, researcher, and your favorite person. Today, I'm here to talk to you about video games and science, and how we can grab both by their necks and make them kiss, consensually. Long story short, by playing Borderlands 3, you can contribute to real-world scientific research, as in data that helps real people in need space. Speaking of need, did you know that more than half the cells in our bodies are alien? Only 43% of our cells are of human origin. The rest belong to foreign microbes. These microbes have a massive impact on our body's health. The more we study microbes, the more we can learn about the accumulation of meat and existential terror that is the human body. These microbes are made up of DNA, just like us. Each microbe has its own special DNA signature, and similar species of microbes have similar DNA. If we can sequence all the different species of microbes found in the human body, which, remember, make up more than half of the cells in our body, we learn a ton about ourselves. To that end, the Microsenate Initiative collected tens of thousands of samples of, to use the scientific term, doo-doo, extracted the DNA of the microbes inside, and sequenced it. Now we just need to organize this data. Unfortunately, though computers excel at certain tasks, like crunching numbers or tracking down specific pornography, they're not so good at organizing DNA information. See, different species of microbes have similar, but not quite identical DNA. That means mapping their sequences can be kind of ambiguous. The computer makes lots of small mistakes that can corrupt downstream analysis. Which brings us back to video games! So, we've got several million sequences that are each 150 nucleotides long, that are riddled with small errors from the computer analysis. How can we get rid of all these errors? With your help. We've taken the millions of DNA sequences and broken them down into bite-sized puzzles that you can play and solve inside Borderlands 3. And try not to think about the fact that the DNA came from human excrement when I use phrases like bite-sized. By playing Borderlands Science inside Borderlands 3, you'll be directly helping our scientists organize and compare this dumb data. The game is simple. You'll be confronted with different strands of DNA, each made up of individual tiles. It's your job to place as many of these tiles as possible in their appropriate row while matching the colors. It's not always possible to line everything up perfectly, but that's okay. By playing the game and matching the sequences, you'll also be identifying the errors in our computer analysis and helping scientists across the planet build a better algorithm for the future. And since all this research is open access, the entire scientific community will benefit from it. This research could directly lead to a universal catalog of all known microbes, which could lead to new breakthroughs in food, medicine, exercise. The sky's the limit. And it all starts with you playing a video game. But if the pursuit of knowledge isn't enough of an encouragement to sort through virtual butt microbes, then fear not. Playing Borderlands Science earns you in-game currency you can spend on booster items for your characters. Oh, and this is all totally free. Just activate the Borderlands Science machine on Sanctuary 3 and sort some gut microbes.
Yeah, that's it.
Thank you so much. Jérôme and Attila. Question time. I guess so.
I can just shout out. Okay. Do you collect data on how often people play? Do they play just once and give up, or do they keep playing? And what drives them to come back? And is there a limit where they reach like, okay, I can't do any more, and then just stop? Or what do you see with player behavior?
So what I know, like the good part of the Borderlands project is because we have comparison points with Final before. So Final was fully open, same principle. I mean, the game design was or full compared to the one hand. But we saw that in final we had something around, in average, people play like 3 to 5 games, something like this. We multiply by 10 that with both online science. The idea is that we have 100 times more people, 10 to 100 times more people, and we have people playing much longer. Of course, you have always the same pattern, right? You have a lot of people playing the easy game and dropping. But Attila has more statistically. I think we have people that play thousands of puzzles easily, and it's the same curve, but the difference, like everything is shifted, and you get one of the magnitude. And I think that highlights also the power of the idea of MMOS. I want to say that we need to use all the expertise that the game industry developed for the benefit of science.
So I could add to that is that it might be strange that we're not deeply analyzing this kind of data, because in the game industry this is like crucial to understand how players react. But in a way, it's kind of part of the core concept that we are in this, let's say, comfortable position that we shifted this responsibility and this burden onto the game developers. So they know it, they do a lot of work on that, they know exactly, and we let them do it. So many of these integrations are primarily driven by the game developers, because they know their community so much better than us would ever understand. So basically that's why we have some information, but we didn't delve into that much so far, because they're doing such an amazing job at CCP and Gearbox.
Okay, another question maybe? Yes, I will give the microphone to Attila.
Yeah, so thank you for truly fascinating talks. So I was lucky enough to play on the arcade in the Museum for Gestaltung in Zurich, and I spent a lot of time playing it actually, and I had no idea I was helping science while playing it. And the reason I stayed there for such a long time is because I couldn't reach the maximum score. And I was wondering whether the target, since you don't know the ground truth, how do you fix this target, this maximum score? Is this reachable or isn't it? I mean, how do you decide like what's the target score?
Yeah, so I mean, first we got a very good point about the game. Actually, to be fair, we worked with team Attila, try to have a now interpretation panel inside with more instructions. It was the very first version that we sent, right? So we know that we have to better show this explain why it's important. Now for the game itself, what's important is we set it up because we have, first, before sending the players to the machine, we have our own agent playing the game itself. So we try to simulate the players to see how far we can push it. And the base code is here to tell you how good what the bar you should reach, but we don't know if you can go higher or if you already reached it. So what we're doing is like we have multiple bots simulating players. We're taking one that the best one, try to lower it a bit to make it sure it's accessible, that people won't get stuck into too difficult puzzles, because it's very important when you play this puzzle and you don't get stuck and just move to a different one. But what it means when you beat the base score, it means that your position, your solution start to be interesting. Because eventually we don't know what is the best solution, and what we're interested to grasp is like if collectively people playing independently the game will converge toward the same solution. Because if they converge toward the same solution, it's potentially because the arrangement of the pattern makes more sense from a visual point of view, but for us a biological point of view, to arrange the data. So the scope, in that when you part the scope, your chances to have valuable answers is sufficient enough to be stored and analyzed.
Okay, sorry, just a final question because we are quite late this time.
Thanks. I've got a question possibly related to machine learning. How do you classify these alignments into levels and how do you score them?
You mean classify kind of the difficulty of it?
Yes.
Difficulty was relatively, so we had different measures to tell us if there's enough diversity, because compared to number, if you have in the different colors, the size of sequences, sometimes there's no need of involving human for that. So that's first filtering that is done about removing the one that the machine would like very well by itself without the help of humans. So you have some metrics to do this. And then after, the way we classify by difficulties is purely in the number of sequences representing the size of the puzzles. And we just ensure behind that the puzzle are interesting enough to be sure they don't send garbage to the interface.
Well, thank you so much. Please applaud.